Hello guys, good afternoon to all. And my name is Mohammed Sabir. In today's sessions, we are discussing about something about quantum mechanics and classical mechanics and some little bit idea of modern physics because it's the general discussions and we want to give us some flavor of that. That's why we are making this video. The first thing is that what is quantum mechanics? In a simple word, quantum mechanics is a it's come from a Bohr's atomic structures model. I think you have a clear cut idea about a Bohr's model. Bohr's atomic structure, it's a origin of a it's a basically the origin of a quantum mechanics. Okay. And how to understand this like how it is powerful because it connects the science with religions. That's a really amazing thing because science is a totally different from a religion. Okay, because science is something about it totally depend on assumption and postulates, but a religion it's something have a like it's a it's a very idea having like about your mind beyond your mind. Okay, that's a different thing and it's a knowledge of soul. Okay, but science is a knowledge of materials. Okay, you have to understand the basic difference between science and religion is that the science is a knowledge of materials and religion is a knowledge of a soul. ये आत्मा का ज्ञान है, ठीक है. And a first thing is that and the basic difference between the classical mechanics and different classical mechanics and quantum mechanics. If you I think let me give you one example. I think this is a wall. Like this is a wall, and when you throw a ball toward this, when you throw a ball toward this wall, basically what will happen? The ball, in a classical manner, the ball bounce back. Okay, but a quantum mechanics says that the ball also can cross this boundary until having this obstacle is there, but it can cross. This is basically a clue. This is basically a turning point of classical mechanics. Like it totally depends on the size of a particle. Like the particle which you are throwing to the ball, what size it having, it totally depend on that. Okay, if its size is so small and the scale of measurement is so small, so it having a tendency, it having a probability to cross the boundary. That's really understandable and really like amazing thing. The in a like if you heard in a first time, so you cannot believe that कि like how it is possible. But if you like, it's a simple kind of modeling. Like practically it is not going to happen, but it's something about modeling of a sciences. Like I think you have an idea about alpha particle decay from a nucleus. Basically it is defined from, like it is explained by a quantum mechanics. Okay, like you know in a nucleus what actually the neutron and protons, not neutron and protons and bound like it's actually it is bounded by some nucleus forces. Like how it is possible that to cross this boundary, to cross this potential difference. So at some state, at this some like it having a probability that if like if you in a like thousands of a thousand of a in a thousand of a chance one one alpha particle and drawn which basically it crosses the boundary of a nucleus. Okay, it really in a first time this is a very like not easy thing, but it's some kind of I want to give some flavor of it, that's why we are discussing that. At the same, the simple thing is that if you should keep in your mind a classical mechanics and quantum mechanics is a totally different things. A classical mechanics Newtonian physics is not applicable in a quantum mechanical things, because it having like just like a Newton play in a classic Newton play a role in a classical mechanics, some same as well uh, likewise the Schrodinger equations play an important role in a quantum mechanics. Heisenberg uncertainty principle, these are the some like fundamental laws, they are applicable, uh, they are applicable in quantum mechanics, and these laws define the quantum mechanics layer by layer. Okay, okay, thank you, all the best.